So this device is a 4-layer. How many layers I am telling? 1, 2, 3, 4 layers. This device is a 4-layer structured device. 4-layer semiconductor material device. It's a 4-layer structured semiconductor material device. As you can see here, P-type, N-type, P-type, N-type. So how many layers now? 4 layers. It's a 4-layer structured semiconductor device having 3 terminals. What are those? A means? What is this? A means? Anode. What is C means? Cathode. What is G means?
Gate.
G means gate. Having 3 terminals, anode, cathode, gate, and having 3 junctions, J1, J2, J3. I'll repeat it. It's a 4-layer semiconductor device having 3 terminals in the diagram only: anode, cathode, gate, and having 3 junctions, J1, J2, J3. Now, how it will operate? By applying the electric field, by applying the potential, by triggering. Another name we can say it as a by triggering. Triggering means in general I tell pinching. What do you mean by pinch? You pinch it, you will get a reaction or she will get a reaction. By triggering a voltage at the gate terminal, by applying a voltage at the gate terminal, by applying a biasing at the gate terminal, this device will work as a switch or it will work as a rectifier. What is the name? Silicon controlled rectifier. What you are doing? You are applying a potential, you are applying a voltage where you are applying at the gate terminal. If you apply certain potential, this device will work as a switch or it can work as a rectifier. Understandable? Say some. Let me elaborate it. Let me give a more definition. This device is a unidirectional device because current will flow from anode to cathode. Even it is called as a unidirectional device. Current will only flow, I am telling only flow from anode to cathode. One direction, single direction. Na dari, raha dari. Whose diagram it is? Super sub, Rashnika. Na dari, raha dari means my way is one way. Like that, it is a single unidirectional device. And you have to elaborate it. You can add it. It is having 3 junctions, J1, J2, J3. Means current will flow from anode to cathode. Always. Understandable? Say some. Now let me give you real-time explanation. Now this device is looking like a diode only. Say some. Symbol, previously I have drawn a diode symbol. I have given a one more terminal, that is gate terminal. What is the speciality of this device? Means this device will work if your AC supply is too high. This device will withstand. What do you mean by withstand? I am giving more power, this is breaking. This is not withstanding whatever the power I am giving. But this device will withstand even if your AC, what is AC? This is your AC. If your AC power is more also in certain devices, it will control that devices. I will give a real time example. Yeah, have you seen in villas, they will have a big lamps outside. It needs high AC. In that, they will incorporate, they will use this SCR to control the flow of AC. For example, sometimes power will go. You will have a dim light, say some dim in your home. Sometimes brightness will be more power. There is a fluctuation in your AC. That can be controlled by silicon controlled rectifier. I will give a real time example. Lamps which are available in the villas, phases. How many in villages will have a phase? Power phase. Say some. First phase 6 hours, second phase 12 hours, third phase 18 hours. Like that they will change. That have to withstand. There they will have this device, silicon controlled rectifier. Power will fluctuate, AC will fluctuate. in order to overcome, the device should not destroy. Whatever the phase should not destroy, it should withstand. There they will use silicon controlled rectifier because it can withstand high amount of AC. The third one is, have you seen motors? Motors they will use for pumping purpose. There also, if sometimes motor will get more power, maybe fluctuation. There also in the motor they will have silicon controlled rectifier. It will help so that your motor will not get affected, your motor will not burst because of silicon controlled rectifier. It can withstand more amount of AC. You provide 240, 250 AC, even 440 AC will withstand. Nothing will happen to your real-time devices. Understandable? That's why SCR is more useful rather than diode. It can be more useful for switching purposes, rectifier purposes in those kind of devices. I'll repeat SCR definition. It's a 4-layer structured device having 3 terminals: anode, cathode, gate. Operation principle: by applying the voltage at the gate, it can be work as a switch and it can be work as a rectifier. You are providing the voltage at the gate terminal. You are biasing it, you are triggering it. Biasing means another name, triggering, potential, electric field you are giving at the gate terminal. Then only this device will work. My meaning is then only your device will work. Otherwise it will not work. Understandable? So yes or no?
Yes, sir.
Okay. Now let me explain you the construction of the device. How it is constructed. As I said, there is 4 layers made up of semiconductor material, P-type and N-type semiconductor material. Listen here, focus here. And anode and cathode and gate are the terminals. Current will flow from anode to cathode. There must be another terminal which can control the flow of current. Understandable? Current is moving from where? Anode to cathode. Current is flowing. There must be a certain control. There must be a control. There must be a terminal. Which terminal will control? Gate terminal will control the flow of current. So gate terminal. That's why gate terminal is called as terminal of control. The flow of current can be controlled by applying the current. By applying the server, or current is flowing between anode and cathode. There must be a one end. There must be another person. In general, I am telling person. In general, there is a terminal. That is gate terminal will control. That's why gate is also called as terminal of control. I will elaborate it. J1. How J1 is formed? J1 is formed by first P and first N-type semiconductor material. What is J?
Junction.
Junction. J1 is this junction. First junction is formed between first P-type and N-type semiconductor material. J2 is formed between second P and first N-type material. And J3 is formed between last P-type and N-type semiconductor material. In the construction you need to write. Everything is in the diagram. 4-layer, 3 junction, 3 terminals, J1, J2, J3, how it is formed, you need to tell. Construction done. Understandable? Now let me go to the operation. What do we know operation? How device works. Working principle. Working principle of the device. What is the working principle of this device? By applying a triggering, by applying a biasing, by applying a potential at which terminal? Gate terminal. Then only this device will work as a switch or rectifier. By I am telling that in generally this device will conduct, this device will work. Only when you apply a potential at gate terminal. Now let me explain the principal operation. What is the first one? Forward locking mode. Focus here, concentrate here. Everything is available in the diagram. And if you know P connection, forward bias, reverse bias, done. Explanation done. This complete topic, I am telling you, what is unit 5? Special purpose devices. this device we are using special purpose. In real time, most of the devices, whatever the chapter consists, topic consists, they will use in real time. They will use in real time application. That's why the name is special purpose devices. For what special they are using, for what is the kind of specialty. And if you know PN junction diode, forward bias, reverse bias, everything is easy. So many times I said it. Focus here. Now what I am doing here? Positive. Negative to M. And if you see here I kept the empty. Means there is no pulse applied at the gate terminal. Which is your gate? Third. 1, 2, 3. Where gate is available? Third B. This is your gate. This is nothing but gate. I write G. Whether I applied any pulse, any voltage here? No. This is empty. I kept gate. It has open. Means what will happen now? J1 will become forward bias. J3 will become forward bias. P2 positive, P2 positive, and to negative. What happens to J2? Anybody in the class?
Neutral.
Tell confidently. J2 reverse bias. Negative to positive, positive to negative. Means if this is reverse bias, this junction will have a depletion layer. I am making it thick. I am writing a depletion layer. If depletion layer increases, what will happen? What will happen? Here I have some majority carriers plus majority carriers are holes. They cannot cross here. Yes sir? Means what it was doing? What is this door? What it was doing now? If you put a door stopper, without opening that door stopper, will you try it? Will you go there and no, blocking. So it was blocking. J1 and J3 will be forward bias and J2 will be under reverse bias. It stops the flow of current. It stops the flow of current. It blocks the flow of current. That is why it is. In which region it is blocking? Forward blocking. This is forward blocking. Understandable? Clear? As simple as it is. You need to put the concept of PN junction diode, forward bias and reverse. Now what is forward? Next, what is this? Forward conduction mode. Same thing. Positive to positive. Negative to negative. What I am doing in the gate? Positive to positive. Negative to negative. Means here I have triggered the gate. Here I am applying the potential to the gate. That is positive potential. In this case, your device will be in on condition. Your silicon controlled file will be in on condition. The only mode in which SCR will be in on condition is forward conduction mode. Forward conduction mode means it carries the current from anode to cathode. The only mode where your device will conduct, because as the principle says, if you bias, if you apply a bias, if you trigger it, device will be on condition. It carries the current. Understandable? Say so. But in real time, this mode is not suitable. It is not preferable because the lifespan of SCR will decreases. For example, they have manufactured it and they have said that the expiry date is 5 years. For example, and you are using in this mode means the lifespan will decreases. It may decrease to 1 year or 1.5 years. Mostly they will prefer that don't use SCR in the on, like most days don't use SCR in the on condition. Understandable? Say some. Now what is this? Reverse means what will happen? What is this? Positive to negative. And negative to positive. And your gate is open. This space, blank space means gate is open. I didn't apply any voltage at the gate. Listen, focus here. What will happen? J1 and J3 will be reverse bias. What happened to J2? As they are in reverse bias, some carriers they will try to cross. They will drift. Drift means they will have some movement. But the device will not be in on condition. It is not in on condition. It is not sufficient to on the device. It is not that much sufficient to make the device in on condition. Understandable? Clear? Session as simple as it is. Few carriers they will drift. Drift means they will move. They will try to move from here. But this depletion layer is present. This depletion layer is present. They cannot move. Though there will be a small leakage current, because this is under forward wire. Some leakage current will be there because some electrons will move. They will give us some leakage current. But that current will not sufficient to arm this device. Now you are giving a AC, that current is sufficient to arm the tube. Here I am telling that this much of leakage current will not turn on the device. Clear? Understandable? Lesson.